not broadcasting.
Good morning, good afternoon, good evening, everyone. This is the Keshe Foundation Spaceship Institute Public Teaching in English for Monday, October 9th, 2017. Understanding Plasma Science Series. Today is part 3 of 12 of the Understanding Plasma Science series, and we're going to dive more into depth on plasma science and nanocoding. And today we have Jim McDonald and Sandra Kakasi with us. I'm your host, Flint Mulhausen. And welcome, Jim.
Thank you, Flint, and welcome everybody to part 3. We hope you are enjoying the first 2 parts. I'll just share my screen. Can you see? Is it coming through?
Yes, nice and good.
Right. So today we're going to just do 2 parts because the nano is sort of a very important part of the whole process. So we wanted to take our time and really go into detail on that one and focus on that one. So today will just be a bit more on the understanding on the science, plasma science, and then we will go into the nano there with Sandro. So this technology is brought to you by the Keshe Foundation, and obviously 2 websites that one can connect to and to get further information. All right, so we're going to kick off into part 3, being on the further understanding of what all the science is all about. First of all, I'll just do a review, going back to our very first workshop, just to bring everybody back up to speed and get our thinking along the same lines. So we begin to understand that everything in this universe and beyond is made of fields. And we introduced you to the concept of magnetic and gravitational fields, which we commonly refer to as maggrav fields. And just to recap on what they really mean, so if we understand, we showed the video of the 2 magnets, so last on part 1. So when the magnets repel each other, we call that magnetical, and when sort of magneticals attract each other, we call that gravitational. And it's the strength of each magnet will dictate that gap that they keep between, And as you saw, as one moves, the other one just repositions and maintains that distance. And when we look at the interaction of the fields between the two magnets or two plasmas, as referred to, so the fields exiting the one, if you look at interact and enter the bottom of the next plasma, and this is how they keep their distance from each other and keep that gap. It's how they interact with each other even though they're not in direct contact. And we had sort of brought to you the understanding that we, from the matter state, we go into the nano, and we showed you a bit of the GANs. So today we're going to look a little bit deeper into what we term as sort of the plasma and the fields that make up the plasma. There's just a nice picture, which we will go on later on today, of the plasma fields that have been put into the ice when we freeze the water. Okay, so when we look at a plasma, we've got to look at the sort of magnetical and gravitational fields of this plasma. And a plasma can be made of millions and millions of fields which come together and interact continuously. It's a sort of dynamic field interaction. Now, when we look at the direction of flow of these fields, this flow really dictates what we call magnetical and gravitational fields, because the magnetical is flowing out or away, and gravitational are the ones flowing in or towards, because they've been attracted inwards. And when we look at sort of further definitions of these two words, when we look at magnetical, we can define it as the interaction of different magnetic fields of different strengths creating the initial seeds of the plasma, where the outward flowing fields are known as magnetic fields. And when we look at the definition of gravitational, it's the interaction of different magnetic fields of different strengths creating the initial seeds of the plasma, where the inward flowing fields are known as the gravitational fields. So that gives you a nice definition of those two meanings. So when we look at the plasma itself, the fields are constantly given out, and what is not needed in the environment is then taken back in to the center. So what comes out comes back in at the bottom, but what comes out from the plasma and is not needed in the environment is then taken back in. So that's the principle when we really go into on depths on the soul side later on. It's the principle of giving and receiving unconditionally, because there's nothing attached to it. It's just given out. What is not needed is then taken back in again. So to sum all that up on what plasma is really about, it can be made of millions and millions of fields that come together and interact continuously. So it's a dynamic field interaction of these fields, and that's what creates the plasma, what we know as the plasma. Now, when we take a look at sort of the world around us, we've been told that when we look at an atom, we sort of have a lot of empty space, and if you try and put that space into an understanding, if we take a golf ball was the neutron, then the electron would be 1 kilometer away. So we have to ask the question then, what is in the space? What makes the electron move in relation to the protons and neutrons in the middle, and what makes them keep their distance, because there is a huge amount of space in between. And essentially then we have to say that this empty space is filled with the magnetic fields. And we can extend this further if we look out into our solar system and we see the sun and we see the planets in our solar system, but we do see a lot of vast empty space. And this is also filled with magnetic fields and magnetic rays. So even though we perceive it as empty, we don't see them. They are filled with these magnetic fields and magnetic rays. So now we're going to have a look at how a single plasma is formed. And there we've got the small video that we have. So I'm going to stop sharing there for Flint.
So this is just an animation showing how a plasma is formed from singular rays.
So as you can see, you've got your two magnetic rays, and when two rays of similar strength find each other, they start interacting, and you start the beginnings in the creation of a plasma with those magnetic rays. And then you start getting a dynamic interaction of these rays forming your plasma. Okay, Flint, thanks very much. I think most of us have seen this video, this small video clip. It's been around a very long time, but it does give you the essence of interaction of these fields.
Okay.
Okay. Okay, so we then have to view that we see the dynamic interaction of these fields. So you've got the magnetic rays coming together, they find a match, and they start interacting with each other, and they start creating that dynamic interaction of these fields. And this is what we call sort of a plasma. And we only see these fields when they slow down enough to become the matter state. You know, that's why these fields are going at, there are different strengths out there. That's why we don't see them. So we only see those which have slowed down enough for us to be able to see it as the matter state. So As you can see, a small plasma we can call an atom or a proton. A bigger plasma is the Earth. The Sun is an even bigger plasma. Our solar system is a plasma. Our galaxy is a plasma. Our universe is a plasma. It's just an interaction of the fields on a different strength, a different scale. Now I'll go into this a bit more detail so that we can understand this concept. So here's the atom is a plasma. Now we can see this is sort of an actual photograph, and you see right in the center is that principal field. And that empty space that we have sort of learnt and had been taught at school is filled with these fields. We just don't see those fields, but they are filled with those interaction of those fields. And we learned last week that our body is also a plasma, which is made up of billions of little plasmas. So all our little cells, which make up our organs, they are all an interaction of fields creating different parts of the body, different parts of the organ, and in total creating a plasma of us. We introduced the same concept last week with the plants as well. Where the different parts of the plant come together to create the total plasma of the plant as well. So everything we can see is just made of the fields. It's just how they come together is what they create, whether it's a plant, an animal, a man, an insect, or stone. So the Earth is a large plasma. We've seen many sort of photographs illustrating the magnetic fields of Earth, coming out the north, coming in at sort of the southern part of the Earth. So we've got to view the Earth as just a large plasma, a large interaction of fields which are creating the planet on which we are living. The solar system in which we have our sun and Earth and all our planets is just another larger plasma that we have to view. And we see our sun and we see our Earth and our other planet, and all the other planets are also just interactions of fields at certain distances within our solar system. Our Milky Way Galaxy is also a large plasma. It can be viewed. And our universe is the same. It's just a larger version of the same magnetic fields of different strength as in the plasma of an electron or proton. So it's still the same interaction of the fields coming together to create what we see as our universe, or our solar system, or our sun, or our Earth, or even ourselves, or the plants. And when we look at the coexistence and the interaction of these magnetic and gravitational field forces, it leads to the creation of a magnetosphere for the entity. So when we look at that atom, it has its own sort of magnetosphere. The Earth has its magnetosphere that we can see. So would our solar system, so would the galaxy. So everything is the same. It's just the scale and the different field strengths. And this boundary is the maximum point of balance or equality between the two magnetic forces, magnetical and gravitational, which creates our magnetosphere. So let's try and put all of this into perspective, something, a different point of view that we can maybe understand a bit better. Here we've got, as we've said, we've got the Earth, our solar system, galaxy, and universe, all as plasmas. So it's just a larger version of the same magnetic fields of different strength as in the plasma of an electron or proton. But what important thing that we have to understand, though, is that when we look at Earth, Earth is within the magnetic and gravitational field forces of our solar system. And our solar system is again within the magnetic and gravitational field forces of our galaxy. We bring the same concept right back down to our bodies when we look at our body and our organs and the cells and the tiny little amino acids. It's just the same, a larger version of the same magnetic fields of different strength as in the plasma of an electron or a proton. And then we can say the same, that the cells are within the magnetical and gravitational field forces of an organ. So hopefully with that you can understand how things all fit together, whether it's on a very larger scale or whether it's within our body or any other organism. So from a single atom, we get molecules, amino acids, proteins, muscles, bones, our blood, our skin. They're all a collection of fields, plasmas, which manifest themselves in different states because of different environmental conditions. And together they create the man, the planets, the animals, the rocks, whether it's our sun, the solar system, our galaxy or universe. And when we look at just the way that we are made up, could we not say that man is like the universe? It's just a collection of planets, solar systems, and galaxies. So, it really puts that into perspective as what we've often heard of, as above, so below. So this is how the plasma operates. It's just the scale that differs, or this different field strength which differs, but it all operates exactly the same. And I just thought I'd bring this one in because I know Rick did ask the question last on the very first part one on terms of gravity. So when we have a look at the Earth and we've got ourselves, you could say that gravity is a measure of the interaction and attraction of two or more magnetic rays or magnetic field systems, or two or more entities with respect to each other's strength and position at any point. And to simplify that, it's essentially two plasma entities interacting and finding their position, and the much stronger one will pull in the weaker ones, the stronger one being Earth and then ourselves. Because we've got to view everything as a plasma and everything in the view of positioning and interaction of these fields. So gravity is due to the interaction of the magnetic fields. And these magnetic fields that make up our body come from the magnetic fields of our sun, the galaxy, and the universe. So nothing in this world or universe can exist without the magnetic fields. This has been the mystery of creation, that everything is made of these fields. And the whole world is made of the maggrav fields. It's the interaction of the magnetic and gravitational fields which create what we see. And the universe is built on the interaction of these fields. These fields are in constant motion, going from one place to another, depending on their strength and depending on their position. And when these fields slow down enough, it becomes the matter state. That's what we can see. So this is not a new science, but just a further understanding of the interaction of the fields that creates everything around us, that creates who we are and everything around us. And as to do some nice experiments at home, just to sort of see for yourself how these fields look. The best ways to do a nice ice experiment at home. And this is the one that we had done very early on. It was great to actually see what these fields look like. So what we had done was we had just filled a little bracelet. You can see the photograph on the left. It's just a small tube that we had filled with water and a small amount of CO2 gas. Oops. There we go. And what we had done was we had filled a bowl of water and we'd put a Glad wrap plastic over that bowl, and then we had placed that ring on top so that there was obviously a distance between the water and that bracelet. And then we had placed that into the fridge. And then we let it was in there for, I think, 2 or 3 days to freeze up. And now you can see the photograph on the left there and the right, how these fields, just from that bracelet, fields interact in, and that ice has frozen those fields in time. So it's a great experiment for you to see. Sorry, these things flipping around. And then when in this particular one, I think it had been in the fridge for a freezer for 2 days at least. And then when we had broken it open, we discovered there in the middle was a perfect round hole where that even after 2 or 3 days in the freezer, it just had not frozen and just remained that hole. So that's your principal sort of field strength there in the middle. So the field forces within the water are so strong that the ice will not complete the freezing process even after 2 to 3 days. And so it just shows you the strong field forces that we're dealing with just from a tiny little bracelet. So it's a nice experiment for you to do at home and play around with. We've done many, many science experiments like this, and so it was always nice, fantastic to see. And you can see then the fields itself, those total interaction of those fields. So as a summary, we can see that a plasma can be made of millions and millions of fields that come together and interact continuously. So it's from the cells in our body to the galaxy in our universe. All is a plasma and operates in the same way. And the whole universe is built on the interaction of these fields. These fields are in constant motion, going from one place to another, depending on their strength, depending on their position. Any questions at this stage? If we can just please keep the questions to the topic that we are discussing today.
Yes, there is a question that came up in Facebook here from a Niall Jordan. Can we learn to use our own plasma in our bodies to cure ourselves by using our mind?
The answer is yes. you'll understand how we can do that.
Okay, we have a Klaus here. Klaus Dieterberg. Did you have a question, Klaus?
No, not a question. Hello, Jimmy.
Hello, Klaus.
Yes, we can work with our plasma, but not from the mind. The mind is not the right instrument for this working. It's a state of being. It comes from your inner being. The mind, the controller. You understand?
Yes, we understand. Yes, it's our soul that will be able to, and we'll learn that in further workshops. Exactly when we get into more details on that, on the soul, we'll see how through our soul we can.
Okay, next one up here is Nicholas Morrow.
Very good. Just getting connected here. Thank you.
Yes.
So we're saying here that plasmas are formed from fields, and then we have them organized in such a way that we get atoms and so forth, human beings, etc. So what I'm wondering is, what is the organizing principle for plasmas that individuate? What causes an individuation? I mean, the one would think of would be a human being, or even an individual tree, or an individual entity of some sort. What organizes the plasmas and their interactions to create individuality?
It comes down to the environment, and the environment in which the fields come together dictates what they will become. Because on Earth here, we are in Earth's environment. We're in Earth's magnetical gravitational field. So the creation of the amino acids and the creation of life on Earth here is very specific to Earth because of Earth's magnetic gravitational fields. Mm-hmm. On another planet somewhere else that will have different magnetic gravitational fields, the same rays coming in will form something else because of the condition.
Okay. Yes, Jim, and if I may add something here.
Please.
One of the basic principles is that the magnetic rays of equal or near equal field strength will interact. So dogs with dogs, cats with cats, elephants with elephants, and so on. Those fields which are of near similar or similar strength, they'll get an interaction. You see a magnet which we all have on the fridge or as a toy or as a tool. It attracts iron because it is giving out magnetic fields of the strength of iron. It will not attract copper or aluminum. Meanwhile, in the nature there are many kinds of magnets. And we can create fields of a specific strength in order to attract something specific. This is how we make, for instance, CO2 kit, which creates fields, which will attract the field strength of carbon, and so on. So at the time of creation of plasmas, we deal with packets of fields. You remember the short video which we have seen earlier, that with animation showing two rays or two fields, how they interact and they entangle one with the other. And this is a very simplified visual presentation. Yes, this one. In the first second, we have seen many. So this is an artistic representation. If you can go to its beginning or to loop it up. Yes, here you see there are many, many rays, magnetical rays or fields. We call these plasmatic magnetical fields, which are magnetical rays which are already free, independent of their source. And these usually come in packets. I remember that slide which said that plasma can be made of millions and millions of such fields. So this short animation just shows one elementary moment of the creation, but it's not showing the full creation of a plasma. For that, please try to get a copy of Mr. Cash's book #1, The Universal Order of Creation of Matters, where in the first 3 chapters you will find more in details how plasma is formed. So yes, they are not just two fields, but you have to understand two fields of similar or near similar strength will interact. But there are many others, some with smaller strength, some with bigger strength, and these will interact too. Sometimes they combine two smaller in order to match the strength of a stronger.
Sandor?
Yeah.
You're taking all my information for the next workshop.
No problem. So this is just to introduce the people that will find out more next week.
Yes, I've introduced this now, and then for the next workshop, where we're doing the plasma, we'll be going to looking into a lot more detail on the makeup of these magnetic rays, and as you were explaining all the details there.
Yes. So you see, you know, from chemistry that there are so many chemical substances which are combined in different shape and form from different elements. And what's the basis of this combination? It's somewhere a matching in the terms of field strength. So that determines which will match with that. And also in this creation of specific elements, it's a common denominator somewhere, which is the equal or near equal field strength. So that would be the shorter answer to the question we have got from Nicolas Morrow. Are you from Mexico? Or no, New Mexico?
From New Mexico. So the question still is maybe this question. We're speaking of these fields being formed of magnetic rays. Well, are there gravitational rays?
So ultimately, gravitation comes out of the interaction of the magnetical rays. So you have to understand such a magnetical ray that it's not something that there is something just a positive or some negative or some just a north quality or a south quality or a giver or a taker, because those aspects are present in every one. And depending on the interaction of them, you can obtain an attraction which we call gravitation, or we can get a repulsion, or which we call a magnetical property. So ultimately, gravitation, it's the result of interaction of magnetical fields and nothing more. So this is the part of the unified field theory of Merantava-Golikesh.
So you're saying that you can have a magnetic field without gravitation?
I'm not saying that in those words.
I'm
Attraction,
trying to understand. But that's what that's the words you were using. Was
let me say attraction or repulsion.
Okay.
Attraction we call gravitation. Repulsion we call in the new terms of this new science and technology magnetical.
Okay, so then when we're using the term that we're operating within magnetic fields, we should be really saying that we're operating within Maglev fields.
Yeah, think about a tube which has a fan inside, and it makes a flow of air inside. So on one end it takes, and on the other end it gives. So that's the property of any magnetic array. It's like an arrow. It has a point, and it has the back of it with the fletching, and it has a direction. Now, in one direction, so it's the same entity, but it has two ends, and it has different observable effect at both ends.
We'll be going into much more detail in the further workshop on those.
We will come back to this Grace to Jim's hard work on the next couple of weeks.
It has to be
very good. Thank you. And
I'm very glad that you have a lot of thirst for more knowledge.
Good.
And we will go to that knowledge, but step by step for everybody to be able to follow. We have to go at a speed which is acceptable for the average. Because for some it's too slow, for some it's too fast.
Very good. So this question of individuation, then we will look at later.
Yeah, individuation comes from similarity of the field strength and nothing else. And then these elementary bits are combined into more complex shapes and forms. And again, you see, we have a common denominator with other animals, but we individuate as man based on similarity.
I see that. So, one of the questions here is this aspect of form and function, that something forms, comes into forms or comes into a matter state, and it has a function, and which one precedes the other. For instance, the heart is an organ, but it only comes into existence because the energetic is there, the function is there that calls it into form. And I just was sensing that there's another principle here that organizes the fields. I don't want to call it a soul element yet, but there's something that organizes the fields into plasmas or groups of plasma energies, even though we begin with an atom or we begin with amino acids.
We will get to that too.
Okay, I'll let it go for now. Thank you very much.
You're welcome. We have to know that always when we talk about the plasma, we cannot study it as itself, separate it from the environment, but also in its relation with its environment.
Yeah, it always has to be considered in what environment it is. And every environment has that different magnetic or gravitational strength here on Earth, even different positions on Earth.
Yeah, I think the idea of positive positioning comes in there as well. It's integrated into that whole thing very much so. Everything
Yeah.
has a positive position, an individual position according to its center, its plasma center.
Look at a piece of cubic sugar, a cube of sugar. How it is? It is sweet, of course, and it is solid. But it is solid until you put it into the hot tea. So always the environment makes an interaction with the entity. And that interaction will determine finally which shape it will have. So the shape of the plasma is determined by the balance of its internal magnetical and gravitational fields and the balance of internal and external gravitational fields of the environment.
I've got a great example I can show. It's a 1-minute video I did with interaction of two balls in a specific environment. Let me show that here. I think it might be applicable. Just a second here. Okay, I think you can see that now.
Yes. Yeah, it comes in good.
Okay, let me play it. I think it's an interesting and fun example of the interaction of fields here. We have two individual entities that are positioning themselves according to each other and their environment and interacting with the environment and each other, and it's not quite done yet.
Yeah, it's pretty cool.
Having a lot of fun there.
Yeah, it's almost like they're living entities when you see a couple of there is a final little turn in that one. When you see these as plasmatic entities interacting with plasmatic fields, then you can understand that it's a matter of the conditions of the environment as well as the internal factors of that particular entity. And so the same as humans in our environment, we're in a way subject to our environment, and we also create our environment at the same time. So we're creating fields and working with the fields and always interacting and moving to another position according to our interactions.
Thank you, Rick. That
Okay,
was a
you're
nice
welcome.
illustration there.
Yes, thank you very much, Rick. That was really, really amazing to show that.
Jim, I have a question.
Go ahead.
Can you hear me?
Yes, I can.
Jim, thanks for putting this program together. I appreciate it. My question is about this term we use for the interaction of the fields, and the term being plasma. Obviously, the same term is used in other senses outside of what we're doing here. I don't know if there's a place for it or not, but is there any way you can kind of make a distinction for us? I mean, you hear about blood plasma and things of that nature. We're using the same word, but I think we mean something slightly different. When is a good time to kind of try to make a distinction for us?
I'll do a bit of work on that one, and then I'll see if I can fit that in on the next presentation, if that's okay.
Excellent. Thank you.
And John Wells, you had your hand up earlier. Was that, did you have a question?
Not hearing John.
Yeah.
I've
Yeah,
got
he's just not just yet. So okay.
Then I've got a couple of questions on the live stream. Maybe we can
yeah, go ahead.
address them. From BJ, is the sun as a plasma affecting this planet right now and draining the oceans? Water is disappearing from beaches twice in Brazil. Is it possible the moving tectonic plates is taking the water into the cracks that are opening up?
Interesting questions, but can we just keep it to the topic, please?
Okay, Gunther asks, is there any idea how the elementary magnetic fields are created?
That's where we'll look into it in the next one, because we will look at individual magnetic rays and what they're made up of. So we'll cover that next time.
Okay, thank you, Jim. Did you have any more there in live stream, Rick?
Not really. There's Gunther says he's would like to give thanks for this marvelous initiative to teach the basics. He thinks it's the most important initiative since the Knowledge Seekers workshops of the Keshe Foundation. So he's saying thanks for that. And that's it from the live stream right now. And do we have any other questions in the...
Yeah, some on Facebook here. From Niall Jordan, and he's asking, is there a supreme being? And does this mean that every plasma field, no matter what strength, has awareness?
We'll understand that every field has a connection with everything in the universe. So we're all connected. Because we all have a principal field of the universe within us. So we are everything, and everything is us.
So behind it, then there's one consciousness or one awareness. It includes everything.
That I cannot answer.
Okay, is there any other questions from anybody else or other panelists here?
Doesn't look like it, Flint, so we'll go on to the next section then.
Thank you, Jim.
Okay. Just please bear in mind, we have to stick to questions relating to this topic, otherwise we will tend to go way off topic with a lot of discussions and questions, and we need to rather stick to what we've been taught for the new people out there. So if I do come across as a bit rude or vague, it's to try and keep the discussion relating to the topic. Okay, so now we'll get into the nano, and in this section we're going to be looking at the nano layering of copper, specifically copper for this episode. Now, there is obviously a lot of different methods out there, and as I'm going through this presentation, Sandor, if you can just, if you'd like to just pop in every now and then and just add as I'm going through to the presentation. Can you see my screen?
Yes, I can.
Okay.
So,
All right. So we have to look at, there are many methods out there that people have come across to create their nano layers. And today we're just going to focus on the hot caustic bath method. In later workshops, we will detail other methods, but today we just wanted to bring across sort of a very important method that people need to use and understand why they are creating their layers. Before we start, it's always very important on how you treat, once you've created your nano layers, on how to treat them. So I wanted to start off with this very first, because we have to realize that, and these are really, really delicate layers that we are creating. And so when you are handling your nano plates or your copper coils that you've created, is to really use gloves and only touch the real edges, and to not move your box around while the process is going on during the nano layering. And just to try and give you an illustration of how really delicate these layers are, you know, we've all, as kids, we've stuck our finger onto those tiny little ice crystals in the freezer. So if you just imagine your nano layers are like that, so every touch you are damaging tiny little layers of your nano. So if you bear this in mind, then you realize how delicate one has to be to handle this material. Okay, so let's start off with our copper. To start off with, we do have a list of materials that one needs to put together. Please bear in mind when you're doing this, preparation is key, to have everything organized and prepared before you even start, because it's no use trying to run around and look for things when you're halfway through something. So one needs is a pair of gloves, very essential, chemically resistant gloves, not any cotton gloves or any other type of gloves. Safety glasses, a plastic box with a lid, and then you will need your caustic soda, or sodium hydroxide, and then potassium hydroxide, chicken wire mesh, wire cutters, your copper plates or wire, or any other thing you're wanting to, copper device you're wanting to nanocoat, and a scale to be able to measure how much caustic soda you're going to be using, and a measuring jug for your water. So these are the things that one has to put together first.
regarding safety, I read here, so please read your materials safety data sheet according to your country's regulation when you buy the caustic material, and take care of what's there, and keep the instructions. So you have to know that caustic soda, it's not a toy. If it touches your skin, it causes burns. If it touches your eyes, it can cause blindness instantly. So, but if you are handling it with care, you will have no problem. So all we learn to handle fire, but we don't put our hand in fire. So same with caustic. If you know how to handle it, it's no problem. When you use it, protect your body. So don't be barefoot or in open sandals, for instance, in flip-flops. Use shoes and use a clothing which can save your skin in case accidentally you would drop a tool or would splash out a little caustic liquid. And it's very good to have at hand a bucket full of water, just plain water. And if you have any drops on the floor or on your body parts or your cloth or your furniture, just use plenty of water to wash it out. Don't use immediately vinegar or other acid to neutralize it, because if you have a little caustic on your skin, if you add some acetic acid like vinegar, you can cause, besides of a caustic burn, also an acid burn. So just wash thoroughly with water every spill off or every drop which goes nearby, and do it in a quiet place without children or pets nearby, and not be surrounded by people who would distract your attention. Take care, and it's safe to use caustic in that case. But safety first.
Yeah, absolutely. Thanks, Sandor. Okay, so yeah, safety first. So always use your gloves, and as Sandor said, have water available to wash off any spills and splashes, because as much as we try and be very careful, things and accidents do happen. So rather be safe than sorry. Okay, so in the preparation, first of all, you have your plastic box, and now we need to create your chicken wire base that will fit into the bottom of your plastic box. So all that one has to do is to take some chicken wire and then cut it to the size of your whatever plastic box that you do have, and just bend the edges of your mesh over, creating a 1.5 or 2 centimeter folded edge. And you just repeat this process on the other side, and eventually you just do it on all 4 sides. So you're creating a sort of a nice box shape, and then that will fit into the bottom of your plastic container. So this is very easy to do, no problems. Right, now your preparation. This is very important when you're preparing your copper plates or even your coils. And just to come back to what we had discussed on the nano layering in the previous episodes, is that at this stage you're just dealing with the copper in a matter state, and so your atoms are all very tightly packed together.
I have here a simple idea which you can keep in your mind. When you do a nano layering of the copper, it's different when other kind of nano layering which are used in industry, where they do deposition by atomic layers or in vacuum or chemical vapors and so on. So when they add something like we add a paint to a surface, here we make the layers from the copper itself. So it's like a kind of process like like when you make popcorn. So you have tightly packed atoms, and then you add an extra energy which makes these atoms to pop up in a different shape and different structure. It's literally like when you make a popcorn.
Yeah, that's why we try and use the term sort of nano layering and not nano coating, because the term nano coating then implies that we are putting something on top of the copper, but we're not, as Sandor explained. Okay, so if you've got your copper, whether it's your copper or it's your wire coils that you're wanting to nano layer, or even your little spinning devices that you have, you need to make sure that they are of the highest quality and purity of copper. Cut them to size that's going to fit into your box with the lid closed. And your plate thickness can vary. If you're wanting to make your plates for your GaNs materials, can vary from 0.5 mil to 3 millimeters. The thickness is not important. Okay, there are two options to prepare your plates. The first one is, if you do have some tools at home, is to drill a small little hole on the two corners of your plates, and these holes can be used to hold your plates during the nano layering process, as well as when you're wanting to use them to produce some GaNs material. The other option is one can just cut into the plates and then bend over small little edges, and then you can use these little edges to hang your plates. So whichever is going to be easier for you, either option works very, very well. You need to clean your copper surface very well, get rid of all the oxidation. Your oil, your fingerprints is all oily and will interfere with the nano layers. So one has to be very careful and clean your material before you place them into the box. Okay, so now we've done all our preparation, and now we can begin creating our nano layers. Now, as a sort of basis standard formula that one can use, Sando has found this one working very, very well, is we're using 40 grams of sodium hydroxide with 10 grams of potassium hydroxide per 1,000 milliliters of water. So
let me add here a little thing. The presence of potassium is very important.
Okay.
So when you buy your caustic soda, sometimes you find its chemical composition that it has, let's say, 90% sodium hydroxide and something is, the rest is something else. If accidentally it contains potassium, it's fine. But usually we add potassium. You can use potassium hydroxide, or you can use a potassium salt, like a potassium chloride, that you can get from any chemist, pharmacist. It's a product which is called no salt in some countries, or salt without sodium. It's a dietetic supplement, so it's easy to buy from any pharmacy. If you cannot get potassium hydroxide due to local restrictions, in that case you can add some quantity of potassium chloride. Potassium is important because a tiny part of the potassium of the nature, 120 parts per million, it's made up of isotope potassium 40, isotope 40 of the potassium, which manifests a so-called beta decay, so it emits some kind of ionizing radiation at a very, very minute rate, which makes it not harmful at all. So some radiation is needed even for life to be able to function. But that little sparks are giving that extra energy which is needed for this popcorn process to occur. So you can use, let's say, 10% of potassium or 30% of potassium, it's up to you. This recipe just was found that this is something which works in most of the cases. So you can use a little more or a little less, you can experiment, but if you use this ratio, your success will be 99% guaranteed.
I have a question, Sandra. I did not understand how the importance of using potassium. Why is it needed in terms of nano layering?
Yeah, look at how cells divide into the body. The division of cells needs some radioactive material, which is usually cobalt, and you can get it in the form of cobalamin. In other names, it's vitamin B12. So vitamin B12 is usually produced in the guts of man or animals and so on. So your body produces it naturally. But that vitamin B12 is needed for the cells to be able to divide. The similar vitamin is the folic acid or vitamin B9 in other terms, which has the same action, but it is much stronger and it's needed for the fetus to grow. So now Mr. Cash has studied for a long time how to find such a material which is slightly radioactive to give that little scintillation for this easy nanocoating process, and he found potassium. Potassium in the nature contains a very tiny amount of isotope potassium 40, which is unstable. So it means it has a longer half-life. I don't remember by heart. You can look up in Wikipedia how many 1,200,000 years or how much it needs to reduce its radiation to half. But all potassium in nature contains that little amount of isotope, which emanates some beta radiation, and that's that one which gives the little spark for this process of nanocoating to occur.
What does it give? The last sentence, please repeat.
A little spark or a scintillation.
Why do we need the spark? I mean, doesn't NaOH itself alone, without potassium?
No, it's a big difference between success and failure if you have some potassium present. If you have no other source of potassium, you can extract it from ashes, from vegetal ashes, from ashes of hardwood. You can just make to collect some ashes from the fire of wood. You can clean it by sieve. Then you put it into the water, you leave it for a couple of days. When you filter it, you can boil it to evaporate some water, and you get a potassium carbonate or a potassium ash, which is called potash. So that contains potassium. You can add that too to the caustic soda.
Okay, so explain in very simple terms what addition of potassium hydroxide does in terms of nanocoating layering. Just gives it a sparkle?
It initiates a nuclear process. It's a nuclear science, don't forget that.
Why is it needed in nanocoating?
For that division of the atoms from the substrate, from the piece of copper to occur. Same like you get the division of the cells in a living body in the presence of the radiation of cobalt, which is contained in vitamin B12.
Okay, so what you're saying is that the potassium hydroxide enhances nanocoating.
Yes. It's a huge difference if you have some percentage of potassium present or not.
Okay, thank you very much.
You're welcome. Just recently I saw a knowledge seeker from Eastern Europe who made new nanocoating, that he tried to make a new nanocoating, but he got a very pure sodium hydroxide, but he didn't add any potassium. And surprisingly, he didn't succeed. Probably when he used the less pure sodium hydroxide that also contained, among other additives or impurities, also some potassium. And now he had something without potassium, and he was wondering why the copper plates were still shiny after he made the process and they didn't change their color. So remember, a little potassium, it's crucial.
Wonderful.
It's like the vitamin for your body, for your cells to be able to divide. Can we go further?
Yes, thank you, Sandor. A lot of valuable information there for everybody. Okay, so you've got your mix, and you can then just sprinkle that onto the bottom of your plastic container evenly to cover the whole bottom. You can then place your plates onto the mesh at the bottom of your container. And just another point on when you're placing your plates, if you can, it would be preferable to position the plate at a slight angle or even vertically, because if the plates are laid flat, then we may observe the pattern of the mesh imprinted on the plates. So it just depends on your size container and how you would like to do it. But ideally, you'd want your plates to be standing upright. Then you need to place your lid onto the box, leaving a small opening. And then you need to pour the boiling water into the container. Now, this is where you need to do a bit of preparation, in that you need to know how much, once you've got your plate in there, you need to know how much water you need to place in there to make sure that your plates are fully covered with the water. So it's best to just measure beforehand with the cold water, see how much water you need. And if you need then 2 or 2.5 liters of water, then you can then know and measure how much caustic soda one needs to place into the bottom of the container. So that all depends on your size of your box and the size of your parts that you're wanting to nano layer. So, but here you have to be very careful when you pour your boiling water in the container, because you're going to get hot steam from your hot water as well as from the caustic. So at this stage, be very careful, and also not to breathe any of the fumes coming off. So you need to pour enough water in there so that you covering your copper plates completely, and then immediately close the box with a lid, and even if you just put your kettle straight back on there or anything else, just so that you can trap that steam in your box.
One of the things I did with my container is I drilled a hole in the lid about 1 inch in diameter, maybe 1.5 inches, so I could attach my lid, get it secure, and then I used a funnel to pour my boiling water through the hole, and that hole then was much easier to cover than dealing with the whole top of the container.
That's a very professional setup, if you can do
Very
it.
good. Yeah. Thank you, because it is a lot safer as well. So thank you for that. Okay, so once you've closed your lid, you leave that box for 48 hours. Do not open the lid during this time, because what you've created in that box is a caustic environment around your copper. All right, the next step is your drying. So after your 48 hours, if you've just doing one single plate, it is a lot easier. You need to remove most of your caustic water from your box. If you do have many plates there that you are trying to nano layer, then one just has to try and remove that caustic with a syringe, because you don't want to really disturb or fiddle with those plates, because you'll be starting to damage any of the nano layers which might be starting to form. And then one must always just leave a small amount of the liquid caustic in the box. So you don't pour everything out, just leave that small little amount that will sit at the bottom of the box.
If I may add here
Yes.
something. So both ways are correct. You can do like in the picture, you just to pour out the caustic liquid from the box, but it is much easier if you can manage to use a pipe to siphon out, to pull out the water without disturbing the entire box. If you have a fish tank or a friend who has a fish tank, look how you take out the mud, the water from the fish tank without turning upside down the whole fish tank. So later, in the questions and answers, I can show my the principle of the method I use usually.
Oh, very
Thank
good. I use a siphon as well, and if it's a smallish plastic tube, you can just fill that with water, and then when you stick one end into the caustic, your finger in the other end, you get an automatic siphon without having to suck it.
Yes, I use exactly the same method. So you have your box with caustic on the table, and you have under the table a bucket, for instance, or another recipient where you pull out the liquid caustic. It's a very good. It's a very easy and good method. Thank you very much.
All right, thank you.
That's important, especially when you are not nanocoating just 1-2 plates, but when you have a bunch of them. When you do this on a higher scale, it's much easier than moving out carefully so many pieces one by one into another box and so on.
It does minimize your handling, so yeah.
Exactly, and you don't touch so much the surface, which I told at the beginning, it's so important to be careful how we handle this very sensitive newly created nanolayers. So at this moment, when you take out the water, usually your copper plates stay shiny metal color until they are covered with caustic. And immediately as you remove the solution of caustic, the color starts to change in minutes.
Yeah, your nano layers begin forming straight away. So it's very important to be very careful how you handle. Okay, so now during this early stage, once you've drained out your caustic liquid, one needs to take a multimeter and drain the voltage from the plates. And the best is to take 2 of your electrodes and do an opposite diagonal corners of your plate. You just hold for a couple of seconds. And if you do this every 6 hours in your first 24 hours after you've drained your caustic liquid.
So why this is important? If you don't do this, the atoms which got in the previous process in the form of a kind of gas around the plate will start to combine with the oxygen and will create those layers of, mainly made of copper oxide, and they create crystalline structures, exactly like the ice flowers are formed on your window when it is very cold outside, when it is frost outside, and you have some moisture inside a heated house. And you see how random shapes of crystals are creating, but if you wish to have a surface where to have a good energy flow, it's good to give a direction from one end to the other. And some voltage appears instantly on the surface of these wet parts, like plates or coils or wires or whatever you want to nanocoat. And when you unite with the wires of the voltmeter, you just allow that voltage to create a current through the measuring instrument and also through the surface of the plate in the space between the 2 contact points of your probes. and that very tiny current of the order of nanoamps or milliamps that will be enough to give an alignment of the crystalline structure which is getting to be formed into the new layers. So it's a procedure to align these layers.
Thanks, Sandor. I've got some
The,
pictures.
the multimeter has a positive and negative. Is it important each time you drain to use the same?
Let me say something. When you measure resistance, so you measure ohms, which you don't do it here, in that case, the multimeter applies the voltage of its internal battery, and always the red is positive and the black is negative. But in case, if you use the voltmeter, it doesn't matter, because the display will show plus or minus voltage. So it acts just very passively. It doesn't give a voltage from inside. It just creates a current between the voltage which you have already on the plate. So it really doesn't matter how you put positive and negative here. Your display will show in one direction, it will show let's say 65.9 volts or minus 65.9 volts like in the picture.
And to be clear, Sandor, it's the draining part that's important, not putting power into the plate. Some people think they have to put power into it somehow, but it's actually...
The voltmeter doesn't put any power.
Right.
If you would use the ohm meter, that would put power, but if you put power, then it will happen that the layers which are already formed will just pop out.
Yes, exactly. That's the way Mr. Kesh explained it at one point, is the layers tend to be too fluffy if there's power put into it. But if you drain the layers of power, then it tends to tighten up the nano layers and it makes them more effective.
So if you have no voltmeter, you just can use a set of wires and in between to put a resistor of high value, some mega ohms. That will do the same job, but it's better that you see and you are conscious about something happens there. So that's why it's better to use a voltmeter. But in case of limited technical possibilities, you can still make a nano coating without a voltmeter, just with a piece of wire where you put in middle in series something of high resistance. If you have no resistor of 10 mega ohms, for instance, you just can cut a stem from a branch of a tree and you take off its cork and you just twist the wires at its their ends, and that will still give that limitation of current. So you can improvise whatever you don't have.
Yeah. That's a great way. All right.
Sorry for too much explanations. We don't want to overcharge the presentation.
It's important because this is such a crucial part of the whole process. So that's why I haven't put anything else for today's just this nano, because I knew it would take a while.
So I've noticed it on my voltmeter that often the first couple of drainings, I get a lot of action, and then towards the latter parts, the sixth or the seventh drainage, there's hardly any register on the meter.
So it depends how much moist you have around. If it's completely dry, probably the voltage which you observe will be less and less.
Oh, good. Thank you.
So here's just a nice illustration of just a clip from the video of the importance of stabilizing and realigning your nano layers that are forming. Because what we're wanting to do is to sort of a line and establish a line of flow through the nano layers, and we do this with the 2 electrodes, so we can dictate the flow through of our nano layers that we are wanting. And these are lovely photographs, pictures from Sandor, where it's just showing you that if we don't align wire, what our nano layers would look like, so they'd be all over the place, so that we wouldn't get a very good flow coming through. Whereas if we do align them, we're now forming a nice flow, a nice even sort of flow of the nano layers, so that when we do pass current through it, it goes through so much better. And the same when one looks at the top picture there with your plates. The red one is if we don't align, and then if we, on the blue one is if we do align at the 2 diagonal opposite ends. We're just creating, we're sort of dictating that flow that we are wanting. And this becomes very important when we're producing the coils for the MagRav units, because you're wanting to dictate the flow of electricity through your coils. So it's very important to know which ones where your electricity is going to be flowing through, in which direction.
So when we're doing plates, the positions of the electrodes, the tips of the meter, there in the structure, it's showing the opposite corners. In one video, somebody did the upper and the mesh, or the 2 upper corners. Is there any one way better than the other?
So if you put on the upper corners, in that case, this will be the way of your flow of electric current. So you get a more uniform surface if you use the longest track. In case of a square plate, it will be the corners. In case of a wire, of course, it will be always the 2 ends.
And what happens if you use like the upper corner in the red, like you have it there, but the black is on the chicken wire mesh?
So you have here the chicken wire mesh. I'm drawing on the left side. And if you apply here, somewhere the 1 pole of the voltmeter, you have here the voltmeter, and you have here the other pole. So in that case, probably you will have something with this direction.
Well, if the plate is touching the mesh, will that influence no matter where you put the electrodes?
So it matters where you put, because let me draw with the blue color. If you put this electrode here, in that case you will get something like this.
The thing is, one of the techniques that used to be used originally was to move the electrode over the whole plate in various spots and just leave it on for a few seconds in each spot. So you're removing the charge from the plate, you're taking charge off, you're draining. You want to drain the plate as much as possible, as well as align the fields like this. So
that has a special purpose in case you want to make GaNs production. In that case, you may want a higher spectrum or a higher range of the fields. So if you put your voltmeter at different random positions, you make 1 layer like this. If you use this point A and B, after 4 or 5 hours, you use these 2 points, for instance, C and D. So the next layers will be aligned in this way. So we'll have a mixture of layers of various directions. when you make the next one between this E and F, then it will come aligned in this way. So we'll have a mixture of directions of the layers, which is very good if you want to make a higher spectrum of fields in case of production of GANs. But in case of energy production, sometimes it's better to have just a uniform flow. Or if you want to make a nano coating for internal part of hemispheres, for instance, in that case, you apply it just once here in the middle, once at the edge, and you apply it only once, and you leave it untouched for the future, because there you may have the purpose to have a very uniform layer. It depends on your purpose. So no method is wrong, but different methods have different effects and different applications, different purposes. But for the beginning, it's good to understand the process itself, and later you can learn some more complex things. It's like when you learn to play at piano. So first you learn such a musical scales, later you learn harmonies, and later you will start to play melodies, and later you start to compose your own music. So here also in process of learning, we keep a similar gradient. So first you learn how to make a nano coating, then how to use that nano coating, and later you go to create your own symphonies with your richer knowledge. For the beginning, it's good to keep it simpler for people who are learning newly to not get confused with too much information at once.
But it does show you the importance of what you're trying to create and for what purpose. So that really comes into play when you're wanting to create complex and intricate devices, and you're wanting to dictate flows. We need to understand why and how.
It's important that learning is not just by listening and reading or watching, but also by doing it. So after you watch, it's very much advisable also to do your own practical applications and experiments, and you will actually learn from what you will do and what you will observe while doing. So when the knowledge adds up.
I think what you're saying there is very important, and Mr. Kesh has brought that up in several of the last teachings over the last couple of weeks, that we have to know what's going on, not just theory, but it's also important to have a beginning point. Some of us have problems that we start experimenting with new things before we even do our first experience.
But that's fine, because even sometimes you learn from your mistakes. I tend to learn more from my mistakes than when you get it right. So that's why you have to practice. You have to play around and do it, because you learn from the whole process. And say there are no mistakes. It's just done differently, and you can learn a lot from that. So don't be shy in playing.
For sure, I would like to say there are no failures. So learning is achieved by a succession of successful and unsuccessful trials or experiments or life experience. You do something and the result is as you wished. In that case, you will repeat that. You do something and the result, it will be not what you wished. In that case, you don't repeat that way. So I used to say you cannot learn to swim without swallowing some water.
Okay, so once you've completed your draining, always put the lid back on. Never leave your lid open. And so we drain the voltage to polarize the surface and dictate the direction of formation of your nanostructures. And so you can do this, as Sandor has shown, in different positions, or you keep your one position where you're putting your electrodes all the time. And then you keep your lid closed for a minimum of 2 weeks.
Let me quote, I don't remember who told this first, but somebody from the first knowledge seekers told once that growing nano layers, it's like growing mushrooms. You need a lot of patience and care.
It's a good analogy.
So, what is happening during these 2 weeks?
Well, during this drying process, the nanoparticles will be finding their position in respect to each other. So you are draining and you're dictating a certain direction, but because they are still wet, they are still moving, they're still positioning, like two little magnets. They've got to find their position in relation to each other. And that's basically what is happening during this process.
How often do you drain during that 2 week period?
Depends on your purpose. If you want to make plates for making GANs, you can repeat that 4 or 5 times each day. If you want to make something for energy, by my knowledge, and please correct me if I'm wrong, you do it once and never more. I'd like to add here something, just a little small drawing here. So if you have here the surface of your copper, and if you have here the atoms in a tight bond, in a metallic bond, as you have underneath, then you make your first layer. Some small particles, atoms, are getting an extra energy due to the hot action of the hot sodium. And like when you melt a piece of ice or a piece of metal, first it goes from solid to liquid, and then it goes in form of gas. So here also we have something like a gas, which is separated from the original plate, but you have a field interaction between these atoms, these copper atoms which are free in a gas state, and between the atoms which are inside. So you have here an attraction, you have a repulsion, and also you have an attraction and repulsion between each. So they find a new position. They want to go a bit further because they got extra energy, but they cannot go too far because of the gravitational forces, the attracting forces. Once you made this, your first layer, and this is arranged, by the way, this gets completed by some oxygen also goes and becomes part of your structure. The copper atoms create some gaps and holes in between where, for instance, the oxygen from the water can fit into. So that's how you get a structure of oxygen atoms and copper atoms. Just I choose randomly another color. Color doesn't mean anything, just a different kind of element. And then you have such a bonds in between. And still there will be some spacing in between. So this to understand how this layering is created. And what's important, once you have your first layer here created, this is your first layer. So now the forces between this first layer and what's inside will pull out more atoms from underneath, and it will pop up another layer. And these created layers also will exert some force over the atoms which are inside the copper, and you will pop up more and more and more layers. So it's literally like when you make popcorn. When you see your nano-coated surface of black color, it means already you have here not 2, not 3, but you have here about tens of thousands of layers of an atomic dimension, of an atomic thickness. So you get about 40, 50 thousands of layers when the color appears black. When you don't see a color change, it doesn't mean you have no nano layers. You have, but they are so thin that they are transparent. So in order to have a solid, such a thick layering, you need that time, those minimum 2 weeks and sometimes 2 months. So more time you let for these layers to get conditioned or created, you'll have a more stable nano layer, which you will find the difference when you are producing ants and you put them into the into the salty water. You will see that some layers will not last too much and some will last for a very long time. It depends how you created them. So for a good job, you have to afford time.
Thanks, Sandor. I think the key here is patience. We have to really take our time in creating these layers. So as Sandor said, after 2 weeks or even ideal 2 months, one can then open the container lid, leaving a small opening. This is important because that change from the caustic environment in the container to the outside environment needs to be gradual. So when you're wanting to stop the process, then you need to at least do this 2 or 3 days beforehand, just by opening that lid slightly and allowing that gradual change of transition from one environment to another. So as Sandor was drawing there, what we've done is we've taken through the heat, we've taken your copper and we've created the nano layers. And so that black that we create, that's 10, 20, 30,000 layers of little balls on top of each other. So those are all your individual layers that one has created. And the importance with these layers then is, as you're creating, you in that direction, you've got superconductor in that flow, because you've now, with your draining, you've positioned your nanoparticles in a certain direction so that the flow is greater. And then in the opposite direction, you've created that super insulator. So that's why it's so important to take time in doing and creating your nano layers. It's not something that can be done in a weekend. And especially for coils, always hang them, never leave them flat. Even when you're storing your coils for later use, always keep them hanging, because even lying them down, the weight of that copper is going to damage the nano layers at the bottom of your coils. You see how delicate these layers are, so always hang when you're storing.
So preferably don't touch them like on the photo. So this was made for the sake of the photo, and when you process, you just use something to hook up the ends of the coils, and you leave it hanging and free without touching anything.
And then washing, it's just, when you finish that process, it's just carefully hold the plates from the corners and just rinse them gently with some distilled water. And please, particularly when you're going to be using them for GANS production, is to please wash all that caustic off your plates before using them in that GANS production. Otherwise, you're going to introduce the caustic into your GANS. So they must be washed before use.
Do you wash them with a cloth or gently with a cloth or anything?
No, you don't touch it, you just rinse it. The water will not damage it, it's very soft.
And some people have suggested putting just a little bit of citric acid into the distilled water. Is that?
It's possible, but only a very tiny amount, and not in the last water. So it's always good to rinse it in 3 or 4 different waters, one after the other. So the water actually dilutes that salts or the caustic soda which is on the surface, and if you wash it in one water, that water will be already a very diluted solution of caustic. So I say you can rinse it first in simple clean distilled water, then in a second container you can add a few drops of lemon juice, for instance, to be sure you neutralize that thing. But when you neutralize it also, it's producing some salts, and you want to get rid of those salts as well. So it has to be followed by rinsing in another clean water and again into the next one. So how many times you can rinse how many plates in a water, that eventually you can measure it by titration if you want to be very much like a technician of chemistry laboratory, but you have to you can just simply follow your intuition and understand that if you wash, let's say, 5 plates into 3 liters of water, it will be cleaner water than if you wash 50 plates in the same quantity of water. Just rinse it, and rinse it. You have probably no running water of distilled water because it's expensive, but you can put 3 or 4 trays with some distilled water. So rinse in first, rinse in second, rinse in third, rinse in fourth, and then put into the container where you want to store them. If you have ever seen such a photo laboratory where they are developing the photographs, it was in fashion in the 70s, and in the 80s it was less and less, so later we use now digital photography. But if you have seen such a lab, you see that they put the exposed photographic paper into a chemical, then they wash it, they put in a second chemical, they wash it, they rinse it again, they put it into the third, and then they put it into a final wash to remove all the leftovers of the chemical. So here we use the similar technique. So you have some trays or bowls or boxes with clean water, and you rinse in first, rinse in second, rinse in third, eventually in the fourth, and you can deem that it's enough clean. You put it in and you move it back and forth for 2-3 times to let the water flow on it, and then you take it out and you put it into the final box where you store.
And if it's not cleaned properly and you use it?
So how you know it's clean properly or not? So best thing is if you can measure it, for instance. As I said, there are methods. One is to measure the pH of the last rinsing water, which is not so accurate, and the most accurate is to use a titration. So measuring the pH could be enough good method for laboratory condition. But usually you don't have such expensive equipment, so you just keep rinsing several times in clean water, and that will be fine.
No, my
So
question.
excuse me, the rinse distilled water or a filtered water?
So it depends how you filter it, because some water filters for drinking water, first they filter out all the dissolved solids and chemicals, and later they add some salts to make a better taste for the water, and you don't want those salts to get into your nano coating. So distilled water is the best, or deionized or demineralized water would be okay. It depends of your filtering, so what kind of filter you have.
Yes, well, we're using a Berkey water filter and not adding anything back into it. And our water is well water, so it's clean water, except probably it has minerals in it.
So you can get $10 worth of cheap TDS meter. TDS means total dissolved solids, and you can measure your clean water, how clean is, how much is the indicated total dissolved solids. If your instrument is calibrated well, you can trust that value. We tend to the perfection, but we never can reach perfect conditions.
I agree. I just, the amount of distilled water that I've purchased, the number of jugs that are around is just excessive.
Yeah, sometimes it happened to somebody to buy from a fuel station so-called distilled water, and when he measured it with a TDS meter, he found out that it has more minerals than his tap water. So you have to trust your source. Alternatively, you can build up your own distiller to distill your own water, so you can get distilled water at 50 cents per liter instead of paying $1 per liter. Or another alternative is if you live in a place where you have plenty of rain and the law doesn't forbid you to collect the rainwater, because we heard such a strange things in some states. In that case, you can harvest your clean water for a clean surface without bird droppings, eventually to filter it further, and that's the best distilled water, which is distilled in the nature. Of course, you don't collect the water, the rainwater from the first 20-30 minutes of the rain, because also you have a lot of dust and smoke in the air, and that's washed with the first rain. But when it rains for at least 20-30 minutes, then you start to get a clean rainwater. So find out that which is suitable to your conditions and location.
My question was to point out, if you don't rinse your caustic plates or caustic off your plates and you use them for GANs, then what?
Wow, in that case, you will add that caustic which is sticking on the surface to your GANs, and that's an undesirable condition. Instead of having a pure GANs, you have a mixture of GANs and some caustic soda. So that's not advisable to use for health applications, for instance. You change the conditions with whatever you add to it. Whatever substances, elements you add into the process, those will be present at the end. So that's why it's good to have a separation, a purification at the end. Furthermore, when you create these nano layers, you create a surface, the order of magnitude of dimension of the atoms, which has a lot of gaps and holes, and if you have caustic on it, those gaps and holes will be filled with sodium or the hydroxy radical or whatever, and the results will be not predictable.
Yes, thank you.
You're welcome.
Also note that it's important not to use your hands, even with gloves on, or a cloth or something like that, to wipe the plates off or try to get the caustic off that way. To just dip it or rinse it in the distilled water. Correct. Jim,
Okay.
there's three
Yeah.
people here with their hands up. I'm wondering if we're ready.
Yeah, we got quite a few people with questions here.
Do we take
Yeah.
questions now, or do you want to continue with your step?
We just got, I think there's 1 or 2 slides to go, and then we open for questions. So
Okay.
It will be better to leave the questions at the end, because otherwise we will never finish.
I knew this was going to be a long one.
Yeah.
Okay.
You were hoping
So-
for 1.5 hour workshops, right, Jim?
Yes. That's
I don't think so.
That's why I didn't even bring in GANs making into this one. I knew.
Well, this is good, though. A lot of really good information is coming out
Yeah.
for people, and it's maybe a little. There's one complaint in the live stream that it's seeming a bit too advanced for the beginners, and most beginners won't want to even deal with this caustic business and so on. But you have to take into account, yes, there's some people that maybe shouldn't be doing this, but they can get other friends that just love doing this kind of thing to do the
Yeah.
plates and so on for them. Or they can
Yeah.
also buy the plates from the Keshe Foundation or other suppliers that are out there. So there are options for those that don't want to get their hands dirty, so to speak.
Yeah. Yeah, this one we've had to go into the detail because it is such a crucial part of creating GANSs and any energy devices. So we've had to do the details so that you really, really understand how important this process is. We couldn't just skip it and dismiss it as just a quick step. People really need to understand how important this is. So that's why we have gone into the details.
Well, it's huge for health if you're giving it to clients or you're giving it to friends to drink or use. It's huge.
Yes, yeah. You've got to know what you're doing. Yeah.
And also one thing to consider is that during this entire process of forming the nano layers, the environment of the wherever you're making this nano coating process affects the nano layers, and so much so that even including your intentions affect the nano layers. Your thoughts, your intentions, your reacting with the plates and everything create a different energy.
Okay, thanks, Flint. Storage. Sandro said this is also very important. Not to damage your layers that you have spent 2 months building and then just to throw them in a box. They have to be handled carefully and stored carefully until you need them. Try and store your plates upright and keep your coils hanging at all times, because they are as delicate as the little feathers there. And this was my pictures on my nano coating right in the beginning, so please don't do what I did. And you want to nano coat as many things as possible all at the same time, because now you are putting things on top of each other, so you're damaging the nano layers. And so please do not do what I have done and what many of us have done. You need to make sure that everything is separate and not touching each other, because you're just damaging the nano layers. And then there is an instructional video. If you go to the YouTube channel and go to the playlist of instructional videos, and there you will see video of nano coating there, as well as some information on the KF Wiki. And then just to finish off your list of materials again, I say it's important to you see it's quite an involved process. You need to really have yourself prepared to know and have everything on hand before you even begin to start this process. So as a summary, you've got to be prepared and have everything organized, and safety is very, very paramount. So your hot caustic process, essentially 2 days, and then your drying, if you want to do your first 24 hours to align the layers with the multimeter, and as Sandro says, depending on what you're wanting to do, you can carry on with that aligning with the multimeter. You leave for a minimum 2 weeks to 2 months with the lid on, and it's only in your last 3 days where you'll have a small opening with the lid to change that transition of the environment. And your plates must be rinsed with the distilled water. And then, as Flint brought up, your intention when this whole process is extremely important, as it will have an effect on your end result. And we will explain, and then you will have a better understanding as why this happens when we get into further workshops down the line in teaching on the soul. You will see why your intention is of utmost paramount. All right, so now we get to the good part, questions.
Okay, where to start here? Well, we do have some attendees with their hands up. I'll bring them in here. We have an Ed Stark. So, or sorry, Denny. Yes, Denny.
Hello, this is Denny. I have 2 questions. The first one deals with the chicken wire mesh. Why do I use chicken wire mesh? Why don't I use stainless steel mesh? What is the purpose of the chicken wire mesh?
So first purpose is to have a support for your copper parts at a distance from the solid caustic. Instead of using a chicken mesh, you can just make a support to hang them at a height some 2 centimeters higher than the level of your dry caustic. It's not a must to use the chicken mesh. So remember, whatever you put into your plastic box when you make the nano coating, so those elements will add to the coating.
Okay. I'm not going to disagree. I think there's a reason for the zinc-coated metal, but let's go on to the second question. Suppose I have never seen a multimeter in my life. What kind of settings, what am I really supposed to know about that multimeter?
Read the instruction manual or the user manual.
But then once I've looked at the manual, how do I interpret what kind of setting I'm going to use when I'm touching the nano-coated plate?
Usually you go for 200 millivolts DC or 2000 millivolts DC or 2 volts DC. It depends of your instrument. You can start with 200 millivolts, which would mean the indication will be between 0 and 200 millivolts at maximum. And if it will indicate such a figure 1 on the left side, it means the voltage which you measure is over the range of 200 millivolts. In that case, you can change it to the next higher level, like a 2000 millivolts or 2 volts.
So I put my meter on a DC reading at 200 millivolts to start with.
DC and millivolts range. Usually the voltages which appear during this process can be of a few tenths of millivolts up to a few hundreds of millivolts. Sometimes it goes over 200 millivolts.
Okay, that's all I wanted to add. Thanks.
You're welcome.
Okay, we have an Ed Weatherall.
Yes. Can you hear me okay?
Yes.
Okay. My questions revolve around the creating of the nano coating, like a popcorn process. And Sandor mentioned the addition of the potassium was important because it's similar. It has some radiation, and it's that's important in like cell division. And that raised the question in my mind is when we're making the nanolayers, are we causing a division in the copper atoms, or are we expanding the existing copper atoms to a larger, like the electrons are expanding to a larger?
You obtain the division from the molecular state, not a division of the atoms. You create a division in the molecular structure. You are not dividing the atoms at this process.
Okay, so each nano particle is created from an original existing copper particle.
Yes, so the copper particles from the surface of your copper piece will get an extra energy. So the electrons orbiting around the nucleus of those copper atoms will change to a new energy level.
Very good, thank you. My other thing I've always wondered is the copper is being exposed to a caustic steam, and that causes the heat and the reaction to cause this.
Sorry, not steam, liquid bath, immersion. There is another process which is nano coating by steam, which we use it when we want to add an extra nano coating on something which already has nano layers on it. So don't confuse that the steam method with the hot caustic immersion method.
Okay, thank you. That answers another question I had. So in the immersion method, it's the exposure to the caustic, and then my question is, after the first layers, and I know you partially answered this, but when the first layers form, and they coat the copper, does that how do the subsequent layers formed? I know you talked about the field forces of the nano layers. Is that what is causing it? Because
yes.
First
yes.
nano layers form, there is no more exposure directly to the caustic environment of the underlying copper.
Yeah, still you have a little moisture of caustic. So still you have some sodium present. And you have the first layers which have been popped out. And that makes a pulling force, and it gives also some extra energy to the atoms which are still into the metallic bond. So more layers of atoms can get freed. So these layers are growing from the bottom up, not from, they are not growing as a layer on the surface and another external layer, but the first layer will pop higher, and then the second layer will follow it, then the third layer will follow it from underneath.
Really?
Yeah.
Okay.
This is what is done in those 2 weeks or 2 months of so-called drying, which is not really drying. Drying is just the last 3 days. I prefer to call it conditioning.
Okay, so just to be, I always envisioned the subsequent layers, the underlying copper atoms, when they were freed, moving through the gaps of the nano layers to reposition themselves above because of some of the diagrams.
Not going through the gaps, but they pop up between the first layer and the metal plate. Or the
So they form underneath the first layer.
Yeah, a nice animation would help very much to understand that process. So, but we have limited abilities to do such animations unless we get more volunteers who have such abilities and the facilities to make more animations, and we could cooperate to make more educational animations.
Okay, thank you. That's very helpful for my understanding. My last question is regarding nano layering by a different process. Do we want to address that, or shall we just wait on that?
So we already passed over the planned 1.5 hours.
Okay.
And that would be another subject, but just for your information, there are many procedures of creating these nano layers. So one is with using gamma layers. This was one of the reasons Mr. Cash was suspected by Belgium authorities for being in possession of gamma radiation sources, and they put him on a terrorist list or whatever, because they didn't understand how was he able to make these nano layers without using gamma rays. So that was in the old knowledge. Also, it's possible to use many other ways to make nano layers, and there are methods which have a common denominator, that you add extra energy to the atoms of the surface.
I was particularly
you can use methods like with heat. You can create nano layers by heat. You can create nano layers by electric energy and so on. So there are several ways.
Well, I was particularly interested. We all know that when we hook up our MagRav units, that the wires begin to nanocoat themselves. And
yeah, that's nanocoating by plasma, and that's the best.
Yes. So is that going to be covered later?
Yes, probably.
Okay, thank you.
Not today.
No, not today.
How about reusing your caustic?
You can reuse it for different purposes. For instance, you can keep the old cold caustic. And this is a method which on January 3rd, 2017, Mr. Cash explained to the Cash Plasma Reactor Group meeting after 2 hours and 41 minutes from the beginning of the video. You can find that video on the YouTube channel of the Cash Foundation Spaceship Institute. And in the factory, they use this used caustic for pre-treatment or cleaning of the new copper parts which are going to be nano-coated. So they put the copper parts, plates or coils or whatever, for a couple of hours into that cold caustic just before to do the nano-coating. So it doesn't make a nano-coating, but that caustic will clean up all the fat and grease which would be accidentally on the surface of the copper. Like, you know, where you use an oven cleaner or a barbecue cleaner, which is basically a caustic solution, maybe a sodium hydroxide or a mixture of sodium and potassium hydroxide. It's a household cleaning, and you see it dissolves all the fat and grease. So same, this cold caustic can be used to clean your future copper parts which are going to be nano-coated. You put them into that cold caustic, you leave for a couple of hours, and immediately from there you put immediately into the hot caustic process. You don't let them on the air. It would be interesting how to recover the caustic from the liquid, but this is a challenge to some industries who are dealing with caustic. It's very difficult to take out all the water of the caustic once it is in solution, because the caustic itself, it's a hygroscopic, so it's attracting the moisture. So let that be a future subject.
Very good. One last question is the container. Here we're using plastic, but there is the option of stainless steel or glass.
Glass is basically attacked by caustic. So you see its surface will change, because glass is a mixture of some chemicals, and some of those chemicals are degraded in the presence of caustic, so glass is not suitable. Furthermore, with high temperature, the temperature shock, the glass may break, so we don't advise using any glass for that. The best is to use a plastic which is heat resistant. And one of these plastics is polypropylene, PP. You find that usually on the bottom of the boxes there is a recycling symbol with a triangle with number 5, if I remember well. But 5, it's for a group of plastics, and usually it's added the letters PP, which means polypropylene. The boxes which are good for food, for put food into microwave, for instance, or for storing food, are usually made of polypropylene, but you have to check. Polypropylene will start changing its shape at about 120 centigrades. And it will melt at, let's say, 140 centigrades. And you have to understand, when you add hot water, boiling water to the caustic, that will increase its temperature suddenly. Depending on the concentration of the caustic, it can rise up to 105, 110, or 120, or 130 centigrades. You see, in the material safety data sheet for caustic, always it says, never dissolve it into the hot water, always in cold water, because it will produce extra heat. So that's for safety. But here, we need that extra heat. That extra heat is part of the process. So you use plastic which withstands that heat. Polypropylene, it's fine. And for storing the caustic, also you have to take care to store it into containers or bottles which withstand the caustic. And one it is polypropylene, and the other is HDPE, high density polyethylene. Never store it into PET bottles, like the Coke bottles or soft drink bottles, because in time the caustic will find its way to leak out, and you don't want a caustic spill that you can put in danger your feet or the pets and so on. So
don't put it back in your distilled water bottles.
I am putting back in my distilled water bottles, but I buying distilled water into HDPE bottles, polyethylene of high density. So it's no problem, but never put it back into the bottles which are made of PET. I could share my camera if the host would allow me to show the difference of those plastics, how they look like.
Yeah, go ahead.
So this is a PET bottle of distilled water. Oh, my exposure is set to nighttime. Sorry for that. Just I have to set it to the normal light. So this is a PET bottle. It's transparent one. And somewhere you can find the symbol here. It's a recycling symbol 1. You cannot see it well by camera. And under it is PET. This is not good for storing caustic. It will make a hole and it will leak. And this is the other kind of bottles. I'm using usually this one. This is HDPE. You see, it's a thicker, it's a stronger, it's a softer plastic but enough hard. Its symbol, it's 2, and it's written PEHD or HDPE. Where is that symbol? It's hard to read it. The camera won't focus on it. But this is suitable for caustic. And always put a label. If you put caustic on it, put a big label there, put a big danger mark, and all the things needed to don't do any accident by confusing what you have in that bottle. That's important too.
Also, earlier there was some, not earlier today, but I mean in the last weeks and months, there was some talk about using crunched up aluminum balls to reanimate your caustic, and that's a big no-no. Correct?
So don't use aluminum in this process. I know people are using it because they have seen a nice video where somebody put pieces of aluminum and they like to copy what's more beautiful. So you have to understand, if you put aluminum into caustic, that will, what effect will have? First of all, it will produce a lot of hydrogen. So more aluminum in caustic, you will have more hydrogen, and you can reach to dangerous conditions. You don't want to blow up your garage or your home. And the second thing is aluminum will get embedded into the nano layers, and when you use it for health, you don't want to have the fields of aluminum, because those can cause something which is well known as Alzheimer's disease. So the problem with aluminum, that in certain circumstances, along with potassium, it can create a field strength which is equal to the field strength of the zinc, and zinc is needed by the brain, but instead of taking the zinc, the brain or the nervous cells, the neurons will take up such a aluminum combined with potassium, and that will not ensure the proper functioning. So stay away of using aluminum in your nano coating, and if you use, you can use that the nano coated things to create energy, but never for health applications.
And that goes to not using an aluminum pot or pan, or even a stainless steel pot or pan for nano coating for health purposes.
So stainless steel, it's an iron which is combined with chromium, sometimes some nickel, but chromium basically, and whatever elements you put in touch with your hot caustic, those will go into your nano coating. If you want something predictable, so please use the plastic that gives good results. Plastic, like polypropylene, is mainly made of carbon and hydrogen, and all these are very neutral, so you have no problems with it. Furthermore, some part of the carbon from that plastic container may build up into your nano layers, which will create such a graphene, such a 5-7% of your nano coating may contain the carbon structures, which is no problem. But you don't want to build in aluminum, chromium, or other metals.
Yes, thank you. Okay, moving on, we have Jalal. Did you have any questions, Jalal? Okay, perhaps he's busy. We have next here on the list. Were you done with your questions, Ed?
Yes.
Okay.
I had one was just raised after that last comment by Sander, but I'll allow other people to go first, please.
Okay, thank you. We have a Peter Heitzberg. Yes, do you have any questions, Peter?
Yes, I did. Thank you. My question is in regards to the 2-week to 2-month period for the nano layering. how important is the temperature of the space that the containers are in with the lid on? Does it need to stay a pretty constant temperature? And if so, what sort of temperature are we looking at?
So heat is an important part of the process. So now this can be a problem for those who have no heated space. So recently I got such a question from somebody who is living on an island somewhere on the Pacific Ocean, and it's winter and has no heating, and it has a temperature of 8 centigrades or something like that. So in that case, you can improvise a heat box to preserve that heat which was created by the boiling water. Just let me share a picture. So I advised for nano coating can use a big box, a cardboard box, a wooden box, does not matter, a box which is bigger than the plastic container. So here is a side view of a bigger box. You can fill it with some insulating material. For instance, just wrapped up newspapers, old newspapers. You put here around. You put inside your plastic box. You put in your caustic, your chicken mesh, your copper plates or copper coils which you want to nano coat. You fill in the hot water, the boiling water, then you put the lid, and then you put an extra layer of wrapped up papers, and then you close the lid. And this thermal insulation will help to keep up this temperature for more hours.
Or if you have one of those coolers, that you normally would put cold drinks and ice in, if it's large enough, just set your box in that and close the lid.
Yeah, the idea is good, but don't forget those are usually insulated with polystyrene, which don't resist to high temperature. So it can melt, or it can liberate some gases which are not very pleasant ones. So you have to use a high temperature resistant insulator. If you have a mineral wool, that would be the best. But if you want to improvise on something which is at hand, then you just can wrap up some paper, like used newspapers, which you get virtually for free. And for the other processes, if you are in a cold place, for instance, gas creation, you have to know that processes are slower at lower temperature and are faster at high temperature. That includes evaporation of the water and the need to replenish with fresh distilled water. But if you are really in a cold place and you don't have, you have no possibilities to heat up all your house, in that case, you can make such a heat box. A box made of wood, for instance, you make such a ventilation holes to not overheat. So such a 40 by 50 centimeters by 70, 80 centimeters or whatever size is suitable for you. Then you can put some electric lamps, not LED lamps, but this normal heat producing lamps with filament, and you have to check the temperature with a thermometer to not overheat it, or eventually you can put a thermostat to automatically set your temperature. So you can overcome these conditions. If you know what are you following, you can find a method how to get over. Or you may laugh, but one of the cheapest ways how to create a constant higher temperature is that used by gardeners in the northern hemisphere when there are autumns, winters, and cold springs. They use the manure. So they have boxes where they put earth and they are growing their seedlings. And they put around a lot of cow manure or horse manure. around, and that makes us, they put some straw. This is manure. They have a lid or something like foil, and this manure is going to make a biodegradation by fermentation by some microbes, and it's producing some heat and also some smell sometimes, and you don't want that smell. But if you are really in the middle of nothing and you have no wood, like the gentleman who was living on an island, and the wood to make fire is very expensive because it's imported, they have no wood to cut on that island, this would be one of the ways. If they have some cows or horses, he can get some manure and to make a heat box with manure even in his garden. And still we'll have here 15-20 centigrades. So such method of heating was used, for instance, by the Kyrgyz people hundreds of years ago. They made a palace of the king of wood, and this was the house, and they put a lot of horse manure around. Yes, it had a specific odor, but it was warm inside without making fire. So if you have such a knowledge, you can improvise, you can use methods for achieving what conditions you need. So this is not a recipe now to be followed by everybody, but those in special conditions, in harsh environment, can think about what can they use to get a proper temperature.
And what would be the proper temperature?
Such a normal, comfortable room temperature, around 20 centigrades is fine, or 25 centigrades is fine. If you are in a colder place, like in your garage out in the winter, you will see the process is not working with the same speed.
Great, thank you very much.
You're welcome. But you can make such a heat-insulated box if you are really in a cold place, and for your nano coating. So a cardboard box, like in which you purchased your microwave or your refrigerator, your vacuum cleaner, or you just get a box from somebody else's waste, and you can fill it with papers, and you put inside your box, plastic box in which you make the nano coating. That can provide a good insulation by the layers of air which are kept in between the wrapped paper pieces. Or if you want to be very professional and you can afford, you can make a double wall wooden box in which you have an insulating layer of mineral wool, like that which is used to put on the walls to make a heat insulation. I wouldn't recommend the polystyrene foam because that's not heat resistant.
I think we'll have time for one or two more questions.
Okay.
We will be covering nano again, so we'll have another opportunity for many questions for Sandor.
Yeah, we got tons of questions here.
Yeah, we'll be here all day.
Yeah, I see a comment from John Wells. Potasio no es solo K40, hay otros isótopos. It's in Spanish language. So the value which you find in the periodic table of elements, usually it's an arithmetic average of the isotopes which are found within the same element. So for instance, you see copper, it shows a molar weight of 64 in the periodic table of elements, but actually you cannot find isotope 64 of copper. Usually you have isotope 63 and 65 in certain ratio, and the average is written on the table of elements, but it would be the subject. Isotopes would be another subject of another workshop. So this is important to know what is written down. It's an ideal figure, and in nature you don't find ideal figures. You find individual properties. You have to make the difference. So you see, on elevators, it's written it's suitable to lift up 5 persons or 350 kilograms, because they consider average weight of a man is 70 kilograms. Meanwhile, I'm 125 kilograms. So how many of me could fit into the same elevator? Same it happens when you work with elements, isotopes, and so on. So everyone is its own characteristics.
Sandor, good day.
Hello, Jala.
Good day, everyone. Sandor, how the best way to preserve the nano-coated plates, the reserve? What is the best way to reserve them?
So in order to store them for a longer time, always close them into closed plastic boxes with a little moisture.
What kind of moisture? Only water?
Water, not alcohol.
Can we put a little bit NaOH in it?
If you keep caustic, in that case, the process of growing will continue. But if you washed, you finish the nano coating, you reach to the desired quality, in that case, you wash and remove all the caustic. In that case, that growing stops, and you don't want to add more caustic on it. You can, for instance, put a few drops, 1 milliliter of water on a paper tissue, and to put it into the same box, and that will maintain some moisture inside. That would be one of the ways to keep moisture enclosed in the box.
Okay, thank you.
You're welcome. Or you get a humidor for preserving cigars with hygrometer inside, and then you can control perfectly that moisture. Have you seen those humidors which rich people who are cigar smokers used to preserve the expensive handmade cigars?
Good idea. I will buy the cigar.
Don't buy that. Don't buy that. It's very expensive. But there is a special box called humidor, which is a sealed box with a air humidity meter, a hygrometer inside, and then you can keep the conditions. Or if you see some kind of cigars packed into a metal tube, always they have a small piece of wood, which is moisture wood, in order to keep a moisture inside. So learn from that. So you put your copper pieces into a box which has a lid, and it closes hermetically. And also you insert a small piece of water absorbent thing you put inside, like a piece of normal paper tissue with a few drops of water, so 1 or 2 milliliters of water. So if you are good in chemistry and in physics and in arithmetics, you can even calculate how many grams of water will maintain what kind of moisture inside.
Okay, I will take your advice. Thank you.
You're welcome. So there were questions regarding fire nano coating, so that will be another time, not today. Okay. About effect of changing of potassium ratio on the nano coating. So if you have more potassium and less sodium, or you can have a nano coating only with potassium hydroxide and no sodium at all, that's also possible. In that case, the spacing between the atoms, the copper atoms in the nano layer will be different, because the potassium gives a different energy level and the sodium gives a different energy level. Yes, it affects. And another question was also from Alex Korik. The picture of the nanoparticles showed 220 nanometers of the electron microscope. Would that indicate a diameter of the copper nanoparticle to 250 nanometer? No, that 250 nanometers or 1 micrometer or whatever figure which is on a picture of an electron microscope photography that indicates the resolution of the photo itself. So usually it's that figure, it's along with a bar made of white and black successive lines, and that would be like a ruler. So 1 unit, either black or white, will be equal to the figure, for instance, 250 nanometers on that photo. So on what you see on the photo, it's something different. It's you don't see the nanoparticle itself on the photo because you don't have such a high resolution picture usually. You see like mountains and valleys, but if you look at a original piece of copper, which you didn't make any nano coating, also you will see a lot of bumps and mountains and valleys according to the degree of finish of that piece of copper. So when you have something very shiny like a mirror and you watch at electron microscope, you still see those bumps there. It depends on how well it's polished the surface to have a very smooth surface. So why we call a nanoparticle, it's because of its magnitude. It is of the order of nanometers, or physicians prefer the measuring unit angstrom for that. Ed Weatherall asked, can we use a heat lamp? What for? To maintain the temperature?
Yes, I asked that when we were talking about creating a box to keep the nanocoating process warm.
Yes, but a lamp will heat up only what is absorbing that radiation. So if there's something reflective, it will have no effect at all on the temperature. So such a heat box where a lamp is heating up the air, it's a different thing. And for nanocoating, you don't need that. If you are in a really cold place, do as I advised, to make a thermal insulating layer around your plastic box. Or if you have electricity, in that case, and you have some extra money to spend, you can find sometimes such a flat heat elements. I saw in some electronics parts supplier, for instance, Conrad worldwide shop, such a heat element with it's like a sticking label. You stick it on the bottom of your fish tank, or you stick it on the bottom of your plastic box, but plastic.
What about like a heating bed for pets?
Yes. So whatever. Yeah, it's fine. That's fine. So if you know the purpose, then you can choose among many ways how to reach that. Particularly, we don't want to give extra light to the nanocoating. If you want to make a nice uniform nanocoating, in that case, you even cover your plastic box with a black box or with a cardboard box to keep the light out. Because you will have a different quality of nanocoating on the side of a plate which was exposed to light, and different quality where it was not exposed to light. If you want to have a very uniform nanocoating, in that case you lock out the light itself. You can just cover it with a blanket or whatever.
So setting your box in the sun is not optimal?
I don't say so. I know some people are promoting such a method that they don't use any hot caustic, they just spray some cold caustic and they put in a plastic bag and they hang it out in the sunshine. Yes, they will produce a black surface, but I'm not sure about what you can do with that quality. Certainly it will be a different quality of coating than that one used with hot process. So anyway, for most of application, we recommend this hot immersion method.
Yeah. Thank you.
Yeah, I think we should wrap things up here.
Yeah.
There's people that
Okay.
think this is a 1.5 hour workshop or now double that time. So we should, we're getting
Yeah,
into a
this
lot
is,
of details, and this wasn't the purpose of the basic plasma teaching here, really.
And we need some subjects also for next week and for the coming weeks too.
Yes, right. There'll be
There's,
lots of opportunities for more detailed questions as we go on here.
yeah, and we'll, like Jim said, we'll be covering nano coding again, correct?
Yes, that's coming up again, different methods, and give an opportunity for more questions.
And I do apologize for the people on Facebook and YouTube. There's quite a few questions there, but sorry we didn't get to them yet.
We do realize we're happy to run over time because we know it is such an important process, and there's many questions surrounding it, and many methods out there. So we do encourage people to please give it a go. It might seem complicated, but if you just do it step by step and follow, you'll realize that it's not that complicated and difficult. So I'd just like to thank Sandor very much on helping to get the correct information put together.
Thank you for the opportunity to speak.
No, and then thank you very much. You have such valuable information for all of us. And thank you, Flint and Rick, for being there in the background and doing your work. So thank you very much, everybody.
And thank Mr. Cash, thanks Merantava Kolikesh for granting to humanity this beautiful knowledge.
Yeah.
Yes, it's actually Thanksgiving Day here, so it's a good day. It's a good day to give thanks and gratitude for all the gifts we've received through this technology and knowledge.
And if possible, please spare the life of the turkeys.
Okay.
They are such a beautiful and lovely creatures anyway.
I'll tell that to my friend that's a turkey farmer.
Yeah, happy Thanksgiving. That's you guys.
Thank you very much, everybody. Thank you, Sandor.
Yes, thank you, Jim.
And we'll see you next week.
Okay. Well, thank you everyone for coming today. This is the Keshe Foundation Spaceship Institute Public Teaching in English for Monday, October 9th, 2017. Understanding Plasma Science series. And we'll close here with some music. And again, thank you for coming.